This is a Total production. Hello Chem Minions, welcome back. This will be our second practice video for chapter 1. And in this one we'll be looking more at condensed and skeletal structures. And then, kind of hinting back at, hey, let's remember those invisible hydrogens that are in our skeletal structures. Alright, so our first structure here, it wants us to give condensed for each of the skeletal structures. So really the thing you want to would probably be the easiest for you to do is in reading this from left to right, you want to pay attention to each of the carbons, right? So I'm going to go ahead and put a dot for each carbon. So when we go and do this, we should see 1, 2, 3, 4, 5, 6, 7, 8 carbons in our condensed structure. And so a lot of times your most condensed form doesn't actually illustrate these double and triple bonds that are here. So what you want to do is go ahead and also put on here the invisible hydrogens. Remember, each carbon has to have 4 bonds. So when it's got 2 like that, I'm going to put 2 there. I'll put 1 here. Was that 1, 2, 3, 4? So that doesn't get any. This guy has 3. That guy has 1. This carbon has none. This carbon has none. And this carbon has 3. Right. So when I start with writing it in a condensed form, I'm reading from left to right. You tend to write your carbons first. So it would be a carbon, and it's got 2 hydrogens on it. So CH2. And then I move to the next carbon, or the next carbon center. So here we have a carbon, and it only has 1 hydrogen on it. So I'll put a CH. All right. Then I come here, and I have this carbon. All right. Now this carbon has a double bonded carbon up here, but it also has a methyl chain that's coming off down here. So what's probably going to be the best is just go ahead and write the CH3, and I'm going to put it in parentheses. That's kind of like the easy way to denote it as a branch that's coming off the main chain. So that's this right here is the CH3 in parentheses. Then I would hop to the next carbon center, which would be a carbon and 1 hydrogen. So I'll put a CH. Okay. Next I have a carbon that has no hydrogens and a second carbon that has no hydrogens. So I'd write CC like so. That's both of those. And then I'd end with a CH3. Alright, this is kind of the absolute optimal condensed form of writing this. But sometimes when you're given a condensed formula, sometimes when there's a double and triple bond, they'll actually show those in the condensed structure as well. So you could have written CH2, shown the double bond, CH, right? Then still did the C and then a CH3 in parentheses. Then did a double bond here, right? Because that carbon's going to get the double bond. And then do a CH. Then do a C, right? And then there's a triple bond between those 2 C's. So 1, 2, 3. Do your second C and then CH3. So technically both of those would be condensed. One is just more condensed than the other. Alright, we look at this guy here. If I go ahead and show all the hydrogens, 1, 2, 3. Alright, this carbon has a hydrogen. This carbon has 2 hydrogens. Alright, so when I go to write this guy up, let me go ahead and kind of block it off so it's easier for us to see it. Alright, so, and let me do this. I'll put a little zigzag there. Okay, so for this one, that's a carbon that has 3 hydrogens, so I put CH3 like so. Then I have a carbon with a hydrogen and an OH. So what you could do is a CH, and then put the OH in parentheses. Then do a CH2. And then this is a carbon with an oxygen and a hydrogen. So a lot of times it's abbreviated as CHO. Alright, that is going to be very important for you to remember. The condensed form of any aldehyde, which we'll talk about later, is CHO, so that's kind of distinctive. Now you could also kind of reduce it being condensed to at least showing the double bond on the oxygen here. So you could have done CH3, a CH, still do the OH, do your CH2, and then you could have done CH with a double bonded O. So that's another way that they could condense it. Okay. All right. And then for this is wonderfully crazy. You have a CH3, you have a CH3, you have a CH3, and then that carbon has no hydrogens, but this one has 2, that one has 2, this carbon right here has 1, and then each one of those are CH3s. So what I would start with is actually a parentheses with all 3 of these branches. Do like a CH3, 3, because there's 3 of them, and then write the carbon. Okay, so that's that carbon right there. Then I'd have a CH2 and a CH2 back to back, CH2, CH2, and then I'd have a CH. Right, so that CH is right here, and then you've got 2 of these CH3s coming off. So I do a parentheses, CH3, 2. Okay, so that's a condensed way of writing that. All right. Next up, we've got this funkiness here. So remember, go ahead and show the hydrogen. So that carbon has 2. That's a CH3. That carbon has no hydrogens. This one has 2. That one has no hydrogens, but this one has 3. So I'd start with a CH2. I'm going to write it fully condensed first. So CH2, and then a carbon, and then this is kind of like looking like a branch, so I'm going to put it in parentheses, right? CH3 in parentheses. So I've got this, I've got that, and I've got this. So now I can move to this guy. So I put CH2, and then I have a CO, right, and then a CH3. Okay. Now the only other thing I could do is I could remove its condensed form just one layer, where I would actually show these double bonds. So you could do CH2 double bond, C, CH3, do your CH2, and then for the CO here, write your carbon, put a double bond on it there, and then do CH3. So either one of those would work in being condensed. All right. So here we have an oxygen that doesn't have any hydrogens, but it's connected to 2 carbons. So I'll go ahead and same thing. Go ahead and draw all the hydrogens. So CH3, 2 hydrogens there, 2 hydrogens there. There's going to be 1, 2, 3 bonds there. So there's 1 hydrogen there. NH2 is fine the way it is. And then here you have a carbon. So that should be a CH3. So when I go to write that as condensed, I'd write CH3, right? The next one would be O. There's no hydrogens there. So then next center would be a carbon, CH2, and then another CH2. So I've got CH3, O, CH2, CH2. Then I got a CH, right? And then I'm going to treat this more like a branch. So I'm going to put that in parentheses for an NH2. And then lastly, I got my CH3 at the end. Okay. All right. There's not really any other way to show that condensed because there's no double bonds. All right. Now if we go and show this guy here, we've got CH3, CH3, CH3. That carbon would have no hydrogens because it's got 1, 2, 3, 4 bonds. This carbon has 1, 2, 3. So it's got 1 hydrogen here, just like this guy up here. So each one of those just have 1. And then this carbon has 2 hydrogens. All right, so in starting to condense, I'd start with these methyls in parentheses like I did up here. So I would have CH3, 3. And then, so I got those 3, so now I do the carbon without any hydrogens. And then I'd have a CH and another CH. CH, CH. And then I'd have a CH2 and then an OH. So CH2 and then an OH. All right. And the only other thing I would do is I could remove one layer of it being condensed by showing that double bond there. So I could do CH3, 3, C, CH double bond, CH, and then CH2OH at the end. All right. Okay, and then our last one for this practice has us determining the number of sigma and pi bonds. All right, sigma is going to be tricky because we have invisible hydrogens. So we want to start with the pi bonds first. All right, and so I'm going to do that for all of them first. So the pi bonds, if you notice, it's one of the double bonds, or it's two pi bonds and a triple bond. So here you have nothing but double bonds. So only count one of them. You've got 1, 2, 3, 4. So this one has 4 pi bonds. Now it's one for a double, but there's 2 pi bonds in a triple bond. So it's 1, 2, 3. Okay. Here we've got nothing but double bonds again, so it's 1, 2, 3. And then here we have double bonds again, so it's 1, 2, 3. All right. Now, in counting the sigma, you count one of each of those double or triple bonds, but you also have to count the invisible hydrogens. So we need to put those guys on there. So I'm going to go ahead and do that. All right, so if I just count the hydrogens, I've got 1, 2, 3, 4, 5, 6, 7, 8. All right, so I got 8 sigma due to hydrogens. Okay, so I'm going to put 8H. Now, in terms of the others, I've got 1, 2, 3, 4, 5, 6, 7, 8. And then plus 8. So I have a total of 16 sigma bonds in this structure. All right, now if I, yet again, remember, I need to go ahead and throw the hydrogens in. So there's 2 here, 0 there, 1, 2, 3 here, 2 there, and 2 there. And then that carbon doesn't have any hydrogens, that nitrogen doesn't have any hydrogens. So I've got, due to hydrogens alone, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 due to hydrogens. And now I just count up all the other bonds that were originally shown in the structure. Remember, count the triple as 1 sigma and count the double bonds as 1 sigma. So it'd be 1, 2, 3, 4, 5, 6. So that would be 15. So this guy has 15 sigma bonds. All right, let's do the same thing here. Let's go ahead and show all the hydrogens. So the only hydrogen there is shown. There isn't any hydrogens there. There's 1 there. There's 1 there. There's 1 there. And there's 1 there. Okay. And then I'm also going to circle the hydrogen on that oxygen as well, because there's a sigma bond between the O and the H. So for just hydrogens, it's 1, 2, 3, 4, 5, 6. So I have 6 due to hydrogens. And then now I count up just the bonds that were originally shown. So that's, and I've already counted this one right there. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. So I should have 8 plus 6 or 14. All right. And next, go ahead and show all the hydrogens again. So that carbon has 2. That carbon only has 1. You notice how the bonding is similar here, right? So that carbon has 2. That carbon has 1. The middle carbon has 1, 2, 3, 4 bonds shown, so there aren't any hydrogens. This carbon has 1, 2, 3, 4 shown, so there aren't any there. And then each one of these carbons has 3. So just from hydrogens, I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 sigma bonds due to hydrogens. Now I count up all the bonds that were originally shown. So remember, 1 per double bond, 1 per triple bond. So it'd be 1, 2, 3, 4, 5, 6, 7. So plus 7. So that means I have 12 plus 7, that's 19. So I have 19 sigma bonds in this structure. All right, so hopefully that kind of helps with your skeletal structures, your condensed structures. And this concludes our second practice video. All right, stay weird.